Welcome student. Today now we start practical problems on sets. Sets means in their union and intersection. It is an important topic according to examination point of view. Before starting the practical problem, we first study the two results. Result 1. If A and B are two finite sets and A intersection B is equal to phi, means they are disjoint set, then N A union B means number of elements in the set A union B is equal to number of elements in set A plus number of elements in set B. This you can check from the Venn diagram. A and B are disjoint set. There is nothing is common to them. So A union B means all the elements of A and all the elements of B. So number of elements in A union B is equal to number of elements of A plus number of elements of B. Now second case, when A intersection B is non-empty. Non-empty means there is some element is there, then number of elements in A union B is equal to number of elements in A plus number of elements in B minus number of elements in A intersection B. You can verify this by the Venn diagram again. Now here A and B are intersecting, means there some elements are common. So we shaded the set A by horizontal line and set B by the vertical line. So we see that in intersection there is a check. So when we add number of elements of A plus number of elements of B, then these elements, those are common to both, are counted twice because they are counted in the set A as well as in set B. That's why here we get the check. Check means these numbers are counted in A as well as in B, but we have to count it only once. So once we subtract them. So when we subtract them, one part is removed. So we get only single part. So NA union B is equal to NA plus NB minus NA intersection B. Remember, whenever in practical problems we have the words like this, or we consider it as union, and word when comes, then it means intersection, because A union B means either elements belongs to A or in B, and intersection means the element belongs to both. So come to the example. Some example is there. Consider. Example is, in a school there are 20 teachers who teaches math or physics. Of these, 12 teach math and 4 teach both. How many teach physics? So we have to find out number of teachers teach physics. So if we denote M is the set of teachers teach math, because math started from M. So we give this set as name M. We can give any name to the set, but our convenient, because M stands for the math and P stands for the physics. So P is the set of teachers teach physics. So we have 20 teachers teaches math or physics. ठीक है, either math or physics. So it means M union P is equal to 20. Of these 12 teach math, so number of elements in set M is equal to 12. 4 teach both, so number of elements in M intersection P, both means in math and physics. So intersection consists of elements 4 and we have to find out NP means number of elements in P. So the formula is M union P. You remember the formula? For the union we add the set NM plus NP minus NM intersection P. I given you formula earlier. A NA plus NB minus NA intersection B. So here replace A by M, B by P. So we get this formula. We put up the value. Union is 20 and M is equal to 12 and P we have to find out its value and intersection is 4. So solving this gives us number of teachers teach physics is 12. Now come to the question number 8 of your exercise. In a committee, 50 people speak French, 20 speak Spanish and 10 speak both Spanish and French. How many people speak at least one of these languages? So here again we assume F as the set of people speak French and S as the set of people speak Spanish. So there are 50 people speak French. So number of elements in the set F is equal to 50. 20 speak Spanish. So number of elements in S is equal to 20. Both speak Spanish and French is 10. And आ गया. So N F intersection S is equal to 10. Now the question is how many speak at least one of these language? Means either French or Spanish. At least one means either French or Spanish. So it means we have to find out the union. So again apply the formula. NF union S is equal to NF plus NS minus NF intersection S. Clear? So put up the value. We get 60 people speak at least one of the language. Now come to the example. Example is in a survey of 400 students in a school, 100 were listed as taking apple juice, 150 as taking orange juice and 75 were listed as taking both apple and orange juice. Now the question is find how many students were taking neither apple nor orange juice. Neither apple and nor orange juice. So here instead of taking A or O, orange for O, we take A as set of student taking apple juice and B as set of student taking orange juice. So here 400 student. So here all of the student neither take, all of the students are not taking all the juices, means apple or orange. Some taking apple, some taking orange, some taking both and some taking nothing of them. So it means here 400 is not their union. 400 is the universal set because in these 400 students, some of students taking neither apple nor orange juice. Clear? If every student like the juice, then this 400 will be their union. But here some of the students which did not like any juice, so 400 is the universal set, number of elements in the universal set. Number of elements in A means apple juice is 100. Number of elements in B means orange juice is equal to 150. And number of A intersection B is equal to 75 means like both juices. Now we have to find out the number of students who are taking neither apple. No apple. No apple means A complement. Because A is the apple juice, set of apple juice. So not A means A complement. Similarly, B is the set of orange juice. So not B means B complement. So we have to find out neither apple nor orange. Nor means and. So it means we have to find out value of A complement intersection B complement. Now, remember the De Morgan's law? When we study the complement of the set, there we do the De Morgan's law. According to that law, A complement intersection B complement is equal to A union B whole complement, because in complement union is changes to intersection and intersection is changes to union. So A union B whole complement, and A union B whole complement is universal set minus A union B. This you can verify with the Venn diagram. A union B means all the elements in the circle A and B. So A union B complement means all the elements of the universal set which are not in the union. It means outside the union. So outside the union means universal set minus A union B. So now we have to find out number of elements in A complement intersection B complement, that will be equal to number of element in A union B complement, and that will be equal to NU minus N A union B. For A union B and A union B, we apply the formula. Put up the values in the formula. We get 225 students were taking neither apple nor orange juice. Now come to the one more example. There are 200 individuals with a skin disorder. 120 had been exposed to chemical C1, 50 to chemical C2, and 30 to both C1 and C2. Find the number of individuals exposed to chemical C1 but not C2. These three parts we have to find out. So here it is given to us that every